No. All right, guys. If there's no questions at all, we're going to get into something. I'm going to take a little bit of a detour because in the next section, we are going to talk about exponential stuff. We're going to talk about exponential functions. So we got to take a detour and talk about functions. So if you go to Canvas right now, you should see under Unit 4, let me go back here. Yeehaw! Under Unit 4, you should see Functions handout. Bam! Functions handout under Unit 4. So if you are able to, pull that bad boy up. If you want to, you can print it out. We're going to go over it, and then we'll see how much time we have left to talk about exponential stuff. We have talked about exponential stuff earlier this semester. You guys remember that? We were talking about money and an account and how it grows exponentially, and we had to determine if something was linear growth versus exponential growth. I know it feels like just about 43 years ago that we did that. Some of you guys are like, if it was 43 years ago, I would be negative 20 years old, Jeff. I'm like, shut up. Okay. So go ahead and get that bad boy. If you just joined, we're going to look at this functions handout from Unit 4, functions handout. Pull that up. Okay. All right. So I'm going to open this in a better way for me here. Hold on. Where did I put it? Donde? There you are. Do. All right. So you should see this thing that looks weirdly biological. I don't know. How many of you guys have ever talked about functions? At some point, you probably have. Functions. When I say the word function, what do you guys think? Anybody? What do you guys think when I say the word function? It could be anything. Just give me something.
I think celebrations.
Say again, sorry.
I think of celebrations when we used to do like functions at work and stuff like that.
Oh, like a work function. Okay, good. I love it. It's not even one that I was thinking about. That's awesome. So a work function. Anybody else? Anything else associated with the word function? Does anyone know what comes to mind?
How something works.
How something works? Okay, I love it. The function of a device or something. I love it. I love it. So the funny thing is, if you think about it that way, the function of a device, if I'm doing like an egg, I have no idea what I'm thinking about this, like an egg whisker. Have you ever seen the one that has a turn and it whisks, the one you have to do by hand? So if you turn this, it translates into motion here to whisk your eggs. And the only time I would do that is if I was making a cake, because eggs are terrible. But that, if you like eggs, you can have all mine, except what I need to make cakes. I like it. Anybody else? Anything about functions? When I say the word function, what comes to mind? Anybody? I wanted somebody to start. What comes to my mind, Jeff, is it is a relationship between a group called a domain. No, it's not. All right. Wafa?
Job or work.
Sorry?
Work or job.
Oh, okay. Your function at work?
Yeah.
Okay. All right. What I think real quick is, has anybody ever heard conjunction, junction? What's your function? No?
No.
Schoolhouse Rock? Okay. All right. Now, in mathematics, a function is sort of related to the egg whisker thing, right? The egg beater thing. In mathematics, now this is a very specific technical definition, but what a function is in mathematics is, well, it's basically this. You have an input, and that input leads to exactly one output. So in mathematics, it's a relationship between variables. A relationship between a group called a domain. So the variables, the input and the output. Now for us guys, you should know this. when I have a function, what normally is the input? Which variable is kind of like normally the input? Anybody? X. And the output would be Y. I love it. So a function is a special relationship where every input has only one output. So if I ask you guys right now, here, let me stop sharing this for a second. Oh shit, now I went to Amazon. Go away, Amazon. Okay. If I ask you guys right now, how big is the shoe that you wear on your left foot? All right, if you were wearing shoes, this normally works better in the classroom because then normally people are wearing shoes. But if I ask you what size is the shoe on your left foot, will anybody be able to reasonably give me two answers to that? If I ask somebody what size is the shoe on your left foot and they said 7 and 8, would that make any sense? Anybody? I don't see anybody anymore, so I don't even know if I'm still here. You guys could all pretend like my Wi-Fi is dead and go, maybe he'll stop class, but I'll just keep talking like a weirdo. Anybody? Am I gone?
No,
No.
just we print the paper. Okay, I use that always. I have my shoes number is 730 or 8. Yeah.
No. If you are wearing shoes,
Oh, okay, wearing no, it
if
has
you are
one
wearing
number.
shoes, and
Okay,
I
when-
ask you,
Uh-huh.
not even then. The only time it would make any sense if somebody was wearing 2 shoes, and you could argue that could happen, Jeff. But be quiet. Somebody's wearing shoes. So Wafa, you would be one input, and you would tell me the size of the shoe on your left foot. Now, why do I say that? Because your left foot and your right foot could actually be different sizes.
No.
So that's why I was very specific.
Uh-huh.
Size of the shoe on your left foot. You cannot give me more than one answer.
No,
So
only one.
Each of you would be an input.
Yes.
For Wafa's input, she would give me a number. For Trisha's input, she would give me a number. For Phoebe's input, Guillermo's input, you would all give me a number. One number. If anybody gave us 2 numbers, we would sort of look at them funny.
Yes.
Right. And I don't want to shame people that wear 2 shoes, but I've never really seen that. So, all right. So that would be an example of a function. For every input person, there can be only one output, shoe size on your left foot. Is everybody with me? Is that? So it's not very mathematical, but that's still a function. What if I ask people, let's see, what's a good example? What if I ask people what instrument they play? Does anyone play an instrument? Does anyone play a musical instrument? Nobody? I mean, I don't play an instrument, so I'm not gonna. Andrew, what do you play? If you're okay with telling me, you don't have to. There we go. So the question, what musical instrument does a person play, would not be a function, because how many outputs did I just get from the input of Andrew? Can you guys see the chat? How many outputs did I just get from the input of Andrew? I like it. Sabrina's got 1. I guess I play table. Yeah, Andrew gave 4 outputs. That would not be a function. So a function is every time I ask a question that's of a person or a function, that's the input. The answer can only be one thing. Table is the best. This is true. It's tricky. It's a lot of practice. Okay, now let me come back to this. I love you guys. So for example, is this an example of a function right here? So I ask, what cars do these companies make? I could say, what car do you have, and what's the type of car? So somebody has a Ford and it's an Edge. Somebody has a Chrysler and it's a Town and Country. 2 people have Chevys and they get Trax and Equinox. I have no idea if they still make these cards, by the way. What do you guys think? Is this a function? Here are the inputs, here are the outputs. So how do you determine if it's a function? Is there any input with more than one output? Can you guys see any input, the domain, that has
Yes.
more than one output? Yes.
Yes.
Which,
Yes.
Should be.
I'm sorry, the chat. Oh, okay.
Should be.
This guy has more than one, so no, this is not. Jeff, why aren't you? No, not a function. It's not a function. All right, sorry, it's my horrible Arnold Schwarzenegger impression. What about this really strange looking thing that looks vaguely, like I said, biological? Oh, some poor little, I'm sorry, put the number 3 right there. Number 3 just kind of went away. Does any input go to more than one output? 1 goes to 4, correct?
Yes.
2 goes to 5, 3 goes to 5. Does any input go to more than one output here?
No.
Good. Is it okay that both of these go to 5? Hell yeah. Hell yeah, it's fine. If I ask people what size shoe do they have, the first person says 4, that's tiny. And the second and third person both say 5, that's fine. Are you guys with me out there at all? So to be a function, every input can have only one output, right? And let me say this real quick. I always got to say this. Has anybody ever heard of the movie or the show Highlander? Highlander? Anybody? Nobody? All right, I'll leave it alone. There's my own personal little joke for Highlander. There can be only one. All right, sorry, I had to get it up. Now look at these ordered pairs. Look at these points. I'm not going to even give you any clues. Can you figure out if these represent a function? Let me ask you this. Let me help you out a little bit. Can somebody tell me what the inputs are in the points? What are the inputs?
Maybe the X.
So tell me what they are.
That means first one, 1,
Keep going.
2, 3, -1, and 1.
Uh-oh. Do you notice something? Didn't I already list that one? What's the outputs? What's the range? Somebody else.
10, 13, -4, 2, and 3.
All right. So is this a function or not? Remember, what do you ask yourself to determine if it's a function? Does any input have more than one output?
No.
What's the output for an input of 1?
10 and 3.
Oh, shit. Let me ask. Did everybody see that? If I have an input of 1, the output could be 10 or 3. So let me ask this again. Does any input have more than one output?
Yes.
So is it a function?
No.
I'm sorry.
I didn't know what to say.
No, sorry. I was
You're
kind
just
of.
like, and I'm like, okay.
So again, guys, if any input has more than one output, so doesn't the input of 1 have 2 outputs? Yes. If I took this point away, it would be a function, because then 1 only goes to 10, 2 only goes to 13, 3 only goes to -4, and -1 only goes to 2. But because this point is there, oh shit. So I asked person number 1, I said, person number 1, how old are you? And they said, I'm 10 and 3. What? So that's not a function. That doesn't make physical sense. It's not a function. All right, let me stop for a minute. So there's kind of 2 levels to this. There's the definition of what a function is. And then now we're going to get into the technical mathematical usage of function notation. Have you guys ever seen this kind of notation, f of x? That's how you say that. You say this, I don't think I say this anymore. F of x, that's how you say this. F of x. Has anybody ever seen that before? F of x?
No. I didn't.
Yes.
Okay. And technically, all that does is it takes the place of y. You see, if I put y equals negative 3x plus 5, isn't that something we've seen before?
Yeah.
What is that the equation of? What kind of thing? Is it the equation of a circle? Is it the equation of a dragon? Is it the equation of a shoe? Is it, what is that the equation of? What would it look like if I graphed it? What would this look like if I graphed it? What is negative 3? What is 5?
That's the -3, the slope, and the 5 is
Whoa!
what?
Y-intercept. So what is it? What would it look like if I graphed it? Would it look squiggly?
That'd be linear.
It'd be linear. Thank you. So this is a linear function. Is that important? Not really. So what is f? What does the function f do to a number that I put into it? It multiplies it by -3, and then it adds 5 to that. That's what it does. That is the function of that thing. That's why we call it a function. Like you guys said earlier, a function, your function at work is the thing you do. They give you this and you do this with it. So the function does something to inputs. Let me see. Where am I? Oh, here we go. Let me erase some of this stuff. So now watch this. The basic usage of function notation is very simple. It's just substitution. F of x is -3 times x plus 5. So what is f of 2? What am I basically saying? What am I letting x equal?
You're letting x equal 2, so you have to plug 2 into the equation.
Exactly. That's all. It's just substitution. Isn't that crazy? That's crazy. And what do you get for f of 2?
-1.
Yes. Can somebody tell me a point that this line goes through?
Two. -1.
-1. There we go. The input of 2, output of -1. That's a point that the line goes through. So one of the most basic and kind of dumbest reasons that we have this notation is so I can see the input and the output. It's not the only reason we have this notation. You guys do part B. Don't say anything. Just do part B. Try. I got a chat. What did I get? Oh, okay. All right. Thank you. And the dragon. Yes, the dragon.
Can I say?
Just a minute. Hold on. Okay, now tell me. Please, please tell me now.
10 -25 is gonna be our point.
Ah, so you put a 10 in. Right, you replaced x with 10. That's all this is. That's all function notation means mathematically. If I'm gonna simplify stuff, it's just substitution. So like you did this and you got f of 10 is negative 25, so it would go through the point 10, negative 25. By the way, this is just an extra. You don't have to necessarily say this, but that's just so you know, that's a point that that would go through. I like that. Oh, there it is. I do say it. Yay, Jeff. All right, look at number 2. Is that a linear function, number 2? Is number 2 a linear function? Is number 2 linear? Anyone? Hello. How did we know this was linear? Because what form is it in? Okay, I got a very tentative answer there. So isn't this in the form y equals mx plus b? Yes?
Yes.
If it can be put in that form, it's linear. Can you put this thing in that form?
No,
Of course not. Why not?
because the squared.
Stupid square. So if I was to graph this, does anyone know what shape it would take? It wouldn't be a,
Really funny looking one.
not really funny. But it wouldn't be a straight line, right? Does anyone know? It would be a parabola, and it would actually be pretty much exactly like this. If you graph that, it would be a U shape. Has anyone ever seen that before? A little U shape, parabola, or more
I've heard of it.
parabola. Okay. So it doesn't change. The way you do this doesn't change. So if I want to do g of -3, I'm going to replace x. Now here's the problem. Don't do this. This is wrong. Got to do this. You're supposed to square the value of x. Minus twice -3. So I would get 9 minus is plus 6. So g of -3 is 15. Whatever this thing looks like, it goes to the point -3, 15. All right. You guys try part B. Do part B. What do you guys get? Anybody get something? What's this?
It's gonna be
-1.
-1.
Wafa came in and beat you. So that would be the answer. And we just kind of know on the side that it would also go through this point. So it would go through both of these points in a curvy manner. Curvy. All right, let me stop. You guys feeling okay out there? Whatever the hell this is, they work the same way. I mean, now is this going to be a straight line? What kind of sucks about this? Where's my variable? Where's my variable?
On the bottom of a fraction.
There you go. So it's going to be really, really freaky. Just to let you know, in case you're curious, if you graph this, let me see if I can make this roughly right. It would look something like this. I have a t-shirt with something like this. Because at 2, what happens if you go to 2? What happens if we try to plug a 2 in here? In fact,
No,
that-
makes sense. Doesn't
Yes.
make sense. It's gonna be 0.
yeah, on the bottom, so that's part B there. On the bottom, you're gonna get a 0. What is that officially? What do we call that? This is not 0. This is not 3. What do we call 3 or something divided by 0? What is that? What do we call it?
No answer for it.
Yeah,
It's wrong.
not wrong. No, it's not wrong. So, everybody, real quick, just to remind you guys, what is 6 divided by 2?
3
3.
over 1.
3. Now, can somebody explain to me why the answer is 3 using multiplication? Why is 6 divided by 2 3 using multiplication? Why is 6 divided by 2 3?
Question mark?
Because 3 times 2 is 6, right?
Uh-huh.
There, yeah. So, all right, so what's 10 divided by 5?
2.
2, because 5 times 2 is 10. 2 is a number defined in such a way that when you multiply it by 5, you get 10. You guys with me? So 3 divided by 0 would have to be a number defined in such a way that when I multiply it by 0, I get 3. Is there a number defined in such a way that when you multiply it by 0, you get 3? What do you always get when you multiply by 0?
0.
Freaking 0. So is there any number defined to do what this needs? No. So what do we
No.
call it?
Undefined.
Undefined. Find. Yeah. Does that strike a bell for anybody? Undefined? I think I explained this to you before, but it's been a little while. But never forget that. There is a reason we call it undefined. There's no number defined that does what this needs. It needs a number that when you multiply by 0, you get 3. No freaking number does that. We haven't defined that. Okay. So here, you guys do part A. That's nowhere near as weird. Uh-oh, I got more chat. I can't keep up with it. Okay. Go away. Guy. This is not, this is kind of nice. Should be kind of nice. All right, h of 5 is going to be 3 over. Replace x with 5. So what is that?
3
3 over 3.
divided by 3, 1.
Okay. So it goes to the 0.51. I like it. Okay, not bad, right? Not terrible. It's just substitution of a number into something. We've done that a billion times. It's just a slightly different notation telling me to do it. That's what these problems are. If x is 5, what's this? If x is 2, what's this? That's all it's saying. That's all it's saying. All right, you guys know, try number 4. There's some nifty ones in number 4. Do number 4. Yeah. Yeah, 4 starts off nice and then it gets weird.
What's the W and the A?
What's the freaking x? Don't overthink it. What do you do with this? What do you do with this?
And plug it in for X.
All right. What if it was a 1 in here? Would you do something different? No, you would plug it in for X. What if it was a 17 in here? Plug it in for X. Whatever the hell it is, a function is defined so that whatever's in here, you plug it in for X. So it's a lot easier than it seems. First one should be easy, right? You plug a 0 in for X. For some reason, I always have somebody do this, and I'm like, how did that 4 survive, right? That 4 is dead. Kill that 4. Where am I at? There I am. Jeff, hello. There we go. So I get h of 0 is -1. Now h of x is 4x minus 1. So what's h of w? Does anyone know? If h of x is 4x minus 1, h of w is
4W minus 1.
4w minus 1. What would h of A would be 4A minus 1. What would h of Jeff be? It would be 4 times Jeff minus 1, whatever the hell that means, but that's what it would be. All right, so this is just the next level up from that. I'm not going to say a word. Everybody try to do this. It works the same way. Kind of look what I did with 4 times Jeff. That'll give you a clue. I like it like that. Do, 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 do. Think it so. Think it so. All right, so let's see. H of x is 4x minus 1. So h of a minus 1 is 4 times a minus 1 minus 1. So I just rewrote x as a minus 1. From the 4, so it's 4 times whatever x is minus 1. 4 times what x is minus 1. No, yes, maybe, no. And then what can I do here? Am I still here? What can I do here? How do you, it's just simple.
Distributive property.
Yeah, distribute. Bam, bam. So I get 4a minus 4 minus 1. So I get 4a minus 5. Bam. Ba-bam, bam, ba-bam, bam. Now, if you look down here, look at these functions. They each of these has a, they're not all functions, actually, maybe here. Each of these shapes has a formula to it. So yes, I could come up with the equation for the word love. Oh, can you guys see how I just need an L and an E? And an E wouldn't be that hard to make. So if I knew the functions, I could make the word love. Ooh, that means math is love. No, stop. So how do I tell from a graph if something is a function? Let's look at this guy first. Where are the inputs on this graph? Where are the inputs? What letter represents input?
X.
X.
So here are the inputs. So like this is an input. So for this input right here, where's the output?
Y.
Yeah, right there. Do you guys see that? Can you see Now, what does it take to be a function? Every input can have only one output. So do you see any input here that goes to more than one output? This one only goes there. This one only goes there. This one only goes there. Do you guys see that? There's no input that goes to more than one output. So this is a function. Check. What about this first one? Is that a function?
No.
Because, for example, this input goes to more than one output. So there's a very nifty test, the vertical line test. If you can draw a vertical line that goes through more than one time, do you see how that lines up with one input having more than one output? So this passes the vertical line test because every single vertical line that I can imagine only goes through once. What about this function? Is this a function?
I want to say no, but it kind of looks like it might be.
Can you identify a place where a vertical line goes through it more than once?
No.
You
No.
see how it doesn't curve back on itself? See how that would be a place? If it doesn't do that, it's a function. So this one is not. This one is. What about this one?
No.
Hell no. Bam! You just need one example where it breaks the rule. And this one breaks it by quite a bit. Poor little dude. No. All right. Oh, let's see. Wow, I got more. Still get all this stuff. My God, are you guys doing all right? We already did this here, so this shouldn't be too bad. Can you guys do this real quick? What's the domain? What's the range? All right, somebody help me out. What's the domain here?
1, 2, 3, 4, 5.
And normally we put it in the little squiggly lines. Squiggly. And then the range, you're just going to read off the other parts, right?
Yep.
-3.
-3 to 5.
I got you. Cool. I like it. Now this is a different representation. But can somebody see what the domain is? What are their starting points? What are the inputs?
1,
1 to 4.
Yeah, 1, 2, 3, 4. And then what's the outputs?
0 to 4.
0, 2, 4. Be careful, yeah. I can't write this like this. I can't even remember if we even talked about this. Did we talk about interval notation?
no.
So I won't do it. So you can't say like 1 to 4 here because that would include 1.2 and 3.9 and no. So you gotta like list them, right? You gotta be careful. Get out of there. Go away. All right. Not too bad, right? Uh-oh. What about this? Oh shit. This is yet a different representation. Domain references what letter normally, what variable?
X.
X. And the range is Y. So can somebody see what the domain is here? What's the lowest X that has an output?
-4.
Does everybody see that? Like -5 is not in the domain because does it have an output? Nope. So -4. Now I can do this because doesn't it include every single number from -4 up to what? What's the last X that has an output?
1.
Does everybody see that? -4 has an output, and then this has an output, this has a blah, 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 blah. And then after 1, it just stops. It's no longer. I have no idea if you guys are with me or not. And then the range, you do the same thing, but you look at the y-axis. So what's the lowest y that actually shows up on the graph?
-5.
You guys see that -5 is right there, but nothing below it is on the graph. So from -5 up to what?
4.
Yeah, past 4, nothing else shows up on the graph. So it goes from -5 to 4. Woo! And this is like a piece of a parabola here. Parabola. This is kind of like a piece of a, what do you call it, Jeff? You can do it. Square root function. But this one's a little bit harder because where does the x's start? What's the lowest x?
You don't have one.
Don't have one. So there's no floor. There's no beginning. So actually it's -infinity. Up to what? From -infinity. Sorry?
2.
Up to 2. That's the last x value, the highest x value that has an output, up to 2. All right, what about the range on the y-axis? What's the first time I see a y value happening?
About 1.5.
No.
We didn't see.
Sorry?
We can't see the start, you know?
Yes, you can. All right, now look, is -1 on the graph?
No.
Is 0 on the graph? Is 0 on the graph?
Oh, yes.
I need you to understand. So watch. Why did we include all the way up to 2? Because every x from -infinity up to 2, if I followed it, see -3 is on the line, -2 is on the line. Now I do the same thing on the y-axis because the range is the y's. -2, aw, -1, aw, 0, aw. Oh, cool, there he is. 0 is on there. What point is this? What point is this?
-2, comma 0.
No, no, no. Come on.
2, 0.
2, 0.
Or 2, 0.
Does y = 0 have a point on the line? Does a point on the line have y = 0?
Yes.
Yes, cool. So therefore the range goes from 0. Oh, let me erase all my weirdness here. Yeah, stop. Now here's the weird part. Do you see how this keeps going up? So is the output of 2 somewhere? Yes. Is the output of 3 somewhere? Yes, if I keep going.
Eventually.
So how far up does this go?
We don't know.
Yes, we do. It goes up
Minus
forever.
infinity.
No, positive infinity.
Positive.
Yes, because look, I'm going 1, 2, 3.
Oh, yeah, yeah. Mhm.
4, 5, 6, 7, 8. I'm going to positive infinity on the y-axis. So for domain, you would look at the x. Range, you would look at the y. All right. Let's not worry about this one, guy. This gets a little bit. All right, let's see what you guys think. What's kind of hard? If I ask you to do this problem, what did I not give you to work with? Is there something that I didn't give you to work with to figure out what that is?
There's no equation.
No equation. What do you expect from me, Jeff? You weird math freak. Hey, calm down. So I didn't give you the equation, but I gave you all the answers. I gave you all the answers. Remember what I kept saying up here? What point does this function go through? Doesn't it go through the point 0, -1? Yes? What point does this function go through? Doesn't it go through the point -3, 15, you with me? So if I put something into a function and I get an output, that is where I would draw a point. So look at this. Why is there a point right there? Because for an input of -1, what must the output have been?
+2.
There, done. 2, done. I don't have to do the work because somebody else already did. When they plotted the points, they were plotting the answers. That's what a graph is. A graph is just a visual representation of all the answers to a given equation. Neat. So don't say this yet. Just think about it for a second. What is f of -2? Don't say it. Don't say it. All right, now say it.
-2.
Yeah, for an input of -2, the output is -2. What about for an input of 5? What's the output? Yes. And look real quick. What point is this? What's this point? What's this point?
-1, 2.
Yes, -1, 2. This point is -2, -2, -2, -2. This point is 5, 0, 5, 0. Do you see the connection? So if I give you a graph, I've given you all the answers to the function. Okay. Real quick, what's the domain? So what's the first time I see the x having an output? Like -5 doesn't have an output.
-2.
Yeah, -2 is the first x value that has an output. What's the last x value that have an output?
5.
5. Yeah, 6 doesn't have an output, poor little dude. So -2 to 5. Now somebody else help me out with the range. If I walk along the y-axis, so sometimes I talk about a little dude. There's a little dude. He's walking on the y-axis. What's the first time he's looking left and right? What's the first time he sees the graph? At what value?
-3.
-3. And then he's walking. He's like, oh, I see it. I see it. I see it there. I see it all over the damn place. So what's the last time he's like, last time he sees it?
2.
At 2, that's the last time he sees it. And he's like, oh man, it's gone. All right. This one's a little weird, but let's see if you can get this. It's kind of like the opposite of these. When is the output -3? For what input is the output -3?
When x is 1.
Yeah, the output of -3 happens when x is 1. All right. Oh my God. You guys doing okay out there? Is this draining? Okay, all right. I think that's the end of that one. Yeah, okay. So let's see. Screw it. You guys want to have an early day? Anybody?
I would love one. I have a screaming baby.
All right. I need more. I don't know. Is anybody else out there?
Yes.
Vote now. I see 3 yeses so far.
Yes.
I'm gonna finish up a project.
4 yeses, 5 yeses. Not enough yet, man. It's not enough yeses. There's people that don't want it to happen. They're like, no. Oh, there's 6 yeses. And still not enough, man. There we go. 7 yeses. We're getting close. I'm curious. 8 yeses. I'm like, one more yes, and then I'll do it. Somebody left already. Damn.
Come on, please.
I think.
I'm here.
And what do you think, Raji? Do you want to keep going or you want to stop? Guillermo, did you answer yet? That's kind of like what I'm doing. I'm trying to figure out who's actually out there and who's not really out there. One more yes, and I'll do it. One more yes. I haven't heard it yet. There we go. All right, guys. We're all done. Let me know if you need to hang out. Otherwise, I'll see you tomorrow, and we'll have a full class tomorrow, so don't get too excited. So let me know if you need some help. Otherwise,
Thank you, Professor.
Sure.
Thank you, sir.
You're welcome. All right, I'm out of here, guys. See you.